In this example, we will compute the inverse Laplace transform of g of s equals 1 over s squared plus 2s plus 2. If we write s squared plus 2s plus 2 in factored form, then we can split the fraction 1 over s squared plus 2s plus 2 using partial fractions. Unfortunately, s squared plus 2s plus 2 cannot be factored using real numbers. So to proceed, we will need to write s squared plus 2s plus 2 in vertex form, s minus h squared plus k. I'd like to note that in general, the vertex form is a times s minus h squared plus k, where a is the coefficient of s squared. However, here, our coefficient of s squared is just 1, so we're using that a equals 1. This process of changing a quadratic in standard form, s squared plus 2s plus 2, to vertex form is also sometimes called completing the square. Let's do this process and write s squared plus 2s plus 2 in vertex form. If you'd like to see the steps of this done out, you can click on the pink link now. Doing this process, we get that s squared plus 2s plus 2 can be written as s plus 1 squared plus 1. Thus, we can write 1 over s squared plus 2s plus 2 as 1 over s plus 1 squared plus 1. To see why this is useful, recall that the Laplace transform of e to the ct times f of t is the function f evaluated at s minus c, where f of s is the Laplace transform of f of t. And here, 1 over s plus 1 squared plus 1 is the function f evaluated at s plus 1, where f of s is 1 over s squared plus 1. And this is the Laplace transform of sine of t. So using c equals negative 1, so s minus c is s plus 1, we get that 1 over s squared plus 2s plus 2 is the Laplace transform of e to the negative 1t times sine of t. And we can conclude that the Laplace inverse of 1 over s squared plus 2s plus 2 is e to the negative t times sine of t.